such a great job last time that you won the job. Your
Thank
host
you. I'm
again.
officially host V2. So we'll give people a minute to hop in. Thanks all for joining Decarb Debrief session 11, actually.
10, 10.
10.
We're not 11 yet. So
Wow.
it's
Lucky
been
number
a
10.
road. Yep.
Very exciting. For those of you who it's your first time joining, welcome. This is a monthly webinar series designed to increase knowledge sharing across our firm. And so if you have a topic, please let us know, either Wendy or myself, but Wendy's really the brainchild behind all of this. We're just reversing roles today, which is kind of fun. So just to introduce myself, I'm Alex Scherf, the Sustainability Program Coordinator here at RMF, and I work primarily with master planning and that team for the University of Minnesota project, but also dabbling in Harvard Business School and Dartmouth as well. And I'm filling in for Wendy again, but this time it's my pleasure to interview her as our subject matter expert today on her findings with Carleton's Passive House student housing project. So as I mentioned, we're going to talk about Passive House today, but Wendy, can you introduce yourself? I know you've been on every
Sure.
one of these calls, but we don't know, like, give us something new to learn.
Yeah. So I'm Wendy Placko. I'm the Sustainability Program Manager. I work alongside Alex and Martha on our sustainability team. I've been with RMF for about a year and a half already, which has flown by and been really cool. And in all of my free time, I am an independent filmmaker. And before I took the job at RMF, I had pitched to a grant agency, the Minnesota State Arts Board, this idea for a documentary film about passive housing in Northfield, Minnesota. And that's actually how Alex and I met. The very first time I met her was asking her about this project. Back in 2021, I engaged in making a short documentary about a housing project that was brought forward by the Community Action Center here in Northfield as a means to create some net zero housing that would be used by people that were experiencing housing crisis and helping them get back on their feet and helping them build their rent history and get back in, choose to stay living there or move on. So it's this very interesting project. Oh, thanks, Juan. Shout out to you. I do love telling stories, and what I do here at RMF is telling stories about the work that we do. And little did I know when I applied for this grant that I would be telling this story in my day job professionally. So it's a very cool way to see these parts of my life overlap. So anyway, the housing development that I made a documentary for was called Hillcrest Village, and my goal was to take a short documentary that I had made back in 2021 about the planning of that project and follow up on it now that it is 2025 and that project is built. So the cool thing about that is the community is going to replicate that project in another community. They're seeing what has worked and they're getting data on the actual use of that building. And so I loved that, but I didn't have any footage of the building under construction. So I actually I weaseled my way into Carleton College, who is doing passive house construction for some dorm replacements on their campus, and got to tour with them about how that's going and really show off some of the elements of passive house design in action. So that is what I'm going to share with you today is a walkthrough of a site that I did back in December and share with you a bunch of these different ideas of what is behind a passive design.
That's amazing. Thanks, Wendy. And I didn't know you were a filmmaker. That's amazing. I mean, I know that we did that film together back
Yeah.
in the day, but I didn't realize you held that title. You wear so many hats that I'm so impressed.
Well, all I have to say is Tommy Deschler, I'm coming for you. He was the RMF's Got Talent winner this past year, but not for long. Just kidding.
Okay,
But
all
we'll see.
right. Well,
Yep,
keep it
yep,
up. Keep it up. Keep up the good work.
yep,
And I'm excited. So I was a board member at the Community Action Center when we built that passive house emergency and low income shelter housing. And I'm just really pumped to see this is the third project that's passive designed in Northfield. So,
yep.
but before we do go into your film, Wendy, could you maybe share a little bit of like the basics about Passive House, especially for those on the call that maybe don't understand that or are hearing that for the first time?
I'm happy to do that. First off, I want to talk a little bit about this phrase, passive house, and where it comes from, because there is a lot of, I guess, some misnomers that come with it. So, first of all, it is a German word, passive house. Oh, those Germans. I guess I want to take a quick moment to say in college, I tacked on a German major, and look, Ma, I'm actually using it in my work life. So the Germans have created this design principle called passive house, and the Germans have this wonderful uh, darling characteristic of taking words that describe something and creating a new noun with it. So passive house is two words, passive, an adjective, and house. But in German, house means a building and not necessarily a home. So that's something that's a little bit different. These principles can be applied to any building, not just a home. And then we have this word passive. So that word, it can be kind of confusing. It's not active, it's just there. So we have the word passive aggressive. You're not being out there about how you're feeling, or you have passive tense, like the in grammar, if you have a ball, that's active versus someone gave the ball to me, that's passive. So the way that the Germans are applying this term here is that this property, this building, is neither giving nor taking in its energy because it is perfectly balanced of it uses as much energy as it saves. So like it is so efficient that it can create as much energy as it uses. And usually what that means is like a solar array is providing a very small amount of energy that it takes to run this building. So that's my German lesson for you on passive house. Does that make sense?
Thank you.
Any
I love
questions there?
that.
Okay. I think it's really interesting because that word house catches a lot of people. So I wanted to go through that. The next thing that I wanted to offer is that there's this idea of there's two entities that can certify a passive house design. There is the PHI, Passive House International, so you can tell that's in German, Passive House Institute. And then we have FIAS. FIAS is the US version of that. And it was once a thing where FIAS was like a chapter of the Passive House Institute, but in the past few years, FIAS has actually broken away as its own entity. And the main reason for the breakaway is that the Germany-based European Passive House Institute had a lot of restrictions on the types of materials you could use, like they approved certain materials, and a lot of those were found in Europe. So that's an issue for those of us that are trying to build projects within a reasonable budget here in the US. Okay, so now I want to talk to you about some basic principles of this passive house design. And I do want to say, just throw out there that it's mostly an architectural principle because it's talking about how do we design a building, but it really does affect the systems that go in a building. So don't worry, engineers, there's plenty for you here. So the first principle of passive house design is that the building is going to be modeled and thought about in terms of its location to the sun. So we're going to be using some age-old principles. Back in the day, people designed buildings thinking about, well, if your windows are west and in the evening you sit in that room in the summertime, it's going to get pretty hot. So passive housing does take into account the directionality of sun and shade, that sort of thing. The next thing that is very important is there is a very thick building envelope is the word that they use in architecture. I'm sure everybody's familiar with that word. So one passive house consultant described it to me of the average building has kind of a light jacket in terms of insulation. Well, passive house has a winter jacket. And the reason for that is because it seeks to have this very cool continuous insulation all around the building. And just so that you know, like it's if you think about it in terms of our value of how insulated are we talking, it's usually like about double of what code would be. So we're talking a very insulated
Double.
exterior.
Wow.
Yep,
That's
yep,
impressive.
yep.
Okay.
So we want this continuous band around a building because that eliminates a concept within passive housing that they call thermal bridges. So what that means is like typical construction might have like where a roof meets a wall, where there is some potential for heat loss to happen. So maybe that's a leak, maybe it's just a conduit for heat to transfer. And so this full wrap eliminates that ability. And in the footage that I'm about to show, the architect Kim from LHB will talk about this more in depth, but it's a really important concept of like, how do we eliminate cold transfer getting through this building? It's also really interesting to think about from a history perspective of so I mentioned earlier, we used to design thinking about sun directionality, and maybe we've come away from that. But also think about like if you've ever seen a building in the Southwest, so like an adobe house from, New Mexico or something. That was something that people in that area, they built really thick insulated walls to keep out that desert heat. So this isn't a totally new idea of this thick insulation, but the thing that is a little bit more innovative is that it's completely sealed. So having something completely sealed provides some challenge or adds some new challenges that engineers are here to solve. So all of a sudden, if we have an airtight exterior, really, we need airflow, and we also have the potential for moisture to build up in this area. So
Yeah, I
the
was
and
thinking like
yeah,
when I was a
it would
teenager,
get
I would take,
stanky in there.
yeah, those long steamy showers where my dad
Yep,
was like, get out, you're wasting water.
totally,
That would
totally,
cause some issues. Yeah, very
totally.
interesting. So what do they do about
Yep.
that?
So they have a very cool air exchange system that they use, and again, the architect will talk a little bit more about that. But what they are doing is they're pretty consistently cycling air from the warm, moist air that's inside and exchanging that with cool, dry air from outside. And of course, there would be dehumidification if the weather outside is not cooperating in that way. But it's interesting because there is some very cool heat transfer that is happening during that in a way that adds efficiency of, we're capturing the heat that we are removing from the space, and we are preconditioning the air that's being drawn in so that we're not, like taking really cold air and suddenly needing to reheat that using energy. So there's some very cool heat transfer happening during that process. So, with that, I want to talk a little bit about Carleton. So, I know it's a little confusing because my documentary is about a different project, but
That's what I was
Carleton,
just gonna say.
yes,
I'm like,
yes,
Wendy, you need to orient us again. So there's
yep,
the Hillcrest project we already did a documentary on.
mhm,
Carlton has two actual
yep,
passive designs. And this
yep.
picture, what is this picture of?
This picture is Lilac Hill, which is their first passive house development. So overall, what Carleton's strategy was, and you can watch the other decarb debrief that we went over for their whole campus strategy. But part of their strategy was replacing some dilapidated old campus housing. So usually honor houses, that sort of thing. And so what they wanted to do was replace that with passive housing as a way to reduce the amount of energy use intensity on their campus. So they pioneered with this small development of kind of a town home layout for student housing, and that includes solar arrays. So, as I said before, passive means that it's generating as much power as it takes. It's so insulated that, as Martha Larson would say, you could heat it with a hair dryer. I love that concept. So they built this, and it's currently running. Students are living in this section. But there are more houses down the way on campus that are currently under construction, and those are the ones that I walked through with the team.
And that's what we're going to see in a minute. Awesome.
Exactly.
Well, Wendy, while you transition to the video, I'm going to put in the chat for everyone the link to all of the decarb debrief sessions. And session 4 was the one that Martha went, myself, and then Mitch Miller, the maintenance manager from Carleton. We talked through what that program was and the district energy heating and cooling system that this will connect to. So just wanted to pop that in there for you all. All the sessions are on the pipeline that Wendy has done in the past, all 9 of them, go soon to be 10. So with that, Wendy, what are you going to show us today now with this footage?
So this is literally a walkthrough with me, a construction manager, the architect. So construction manager is Brandon. Kim is our LHB architect that walked through the project. And then we also have Rob Hansen, who's the campus energy manager. So he's responsible for the district plan at Carleton. And they were kind enough to show me around and point out some of the things that align with these principles that I was just showing.
Well, should I give you a little background on how we ended up with Passive House?
Yeah.
Okay. So we worked on this starting about 3 years ago, and the college's carbon goals basically said that in whatever we do, we can't increase and we want to decrease the carbon footprint of the campus. So we started by looking at the 14 buildings or 14 houses that we removed, and we created an energy budget by taking the total heat and electrical and gas loads of those buildings. We calculated what the energy use of those buildings were, and one of the terms we use a lot of is energy use intensity, so EUI, and it's measured in terms of kilowatts per square foot per year. So those houses had an energy use intensity of about 57, which is kind of an average building. And so we knew that what we did, we could only, for all of the buildings that we were doing for housing, as well as with Shack, and a couple other smaller buildings, we had to do all of that using less energy than the 14 houses we've removed. So when we took what the building program was for all of that, we came up with a number that said we have to make this project work with all of the buildings being below 25 kBTU. So energy use is more than half the energy per square foot from the buildings we were removing. So the
less than half.
Less than half.
Yeah. Mm-hmm.
We needed to be less than half of the energy per square foot than the houses we were removing. And the only way to get down to under 25 is really to do Passive House. And so that's where the strategies that we get into in terms of construction are thermal envelope for wall, ceiling, and actually under the slab, windows, and then there's analysis about shading of windows and how do you make it tight, and then the issue of thermal transfer, so cold going through a wall. And so that led us to building exterior walls that both have a very thick insulation, about, in the case of walls, maybe 50% more insulation than a new good building, but also minimizing thermal bridging and making it very tight. So the construction of the walls typically here are a lot of rigid insulation on the outside of a regular wall. So there are kind of two different wall assemblies. Then there's an interior layer that is kind of a sacrificial layer because electricians and plumbers normally make holes. They're really good at making holes. Mm-hmm. But to make it work for a very tight building, we gave them a place where they don't have to make holes. So that's kind of the way we designed the wall assemblies, is that combination of insulation and then taking constructability into account in terms of how do laborers and the trades normally do their job, and rather than trying to invent a new way of building a wall. So it is a different wall, but it's kind of familiar, I would say.
It's different, but yes, very familiar. So my background, I came from originally framing houses, and then I did a lot of apartment work. And so the work I'm used to is essential basic construction, 2x6 exterior wall, 16 inches on center. Your electricians are all run inside of that wall. And that's just gets insulation, maybe some rigid on the outside, air barrier, stuff like that. Well, the goal here is, like as we've stated, is like this sacrificial, so to speak, wall, that it's not affecting air leakage or air movement, coming in from the outside or losing it from the inside, and so everything's sealed separately, and then you have a wall that is just in there for people to be. So it's just essentially an interior wall that doesn't really communicate with the exterior.
So if you're gonna hang a picture, go to town. It doesn't matter.
We aren't hanging pictures.
Oh, never mind.
We are not putting holes in the, no.
So one of the differences between building either apartment buildings or multifamily construction like this and a house is when you do a house, you've got the buyer or the owner, you've got the builder, one or two people, you might have some testing people, and you might have a designer. And in a house, those people are around all the time. The owners walk through all the time.
Because they live there.
They live, well, or they're going to live there,
Oh, right, okay,
and they
yeah.
want to come and see it.
For sure.
And if there's a hole inadvertently made, and a contractor is there, they know who's done it. And they're there all the time. When you switch to multifamily, you know, Brandon, there are a lot of people who are from the general contractor that are here. There are people from the college that are here. There's the design team that are here. But there's simply no way you can catch every person who's working in the building who happens to put a hole in the wall inadvertently.
Right.
And you won't know it until you're blower door testing it at the end. And either it works at that point or it doesn't. And then you have to try to figure out, so what's not working? Because you do that anyway. Even with all the care we take in terms of the design, there still are things that happen. And so you have to trace it down. So when we're going along, Tara is blower door testing at multiple phases in construction, not just waiting to the end. And so did you do one today?
No, that's on Monday.
Okay,
So
Monday.
we have our first one on Monday for U5, where we've essentially made all of the exterior penetrations that are required, and we're going to close up and seal up certain doors and windows, and then we're going to test the building and see where we come at. That way we can kind of see, okay, we shouldn't have any more that need to go out this building, or any of them leaking. We can kind of pinpoint before we cover up. And so we're taking these extra steps to, we call it like a midpoint testing. And it's just, I mean, overall beneficial for everything. Yeah.
And each time you learn lessons. So the first time they did a blower door over on our prairie site that's finished, and there were a lot of things that were not done yet. But they thought that we've done all we can and this is going to pass the first time around. And,
Yep.
you know, it didn't. And they were pretty
one
surprised.
One of the things we had saw was floor drains. Well, the traps hadn't been filled with water.
Oh,
and those,
yeah.
I mean,
Yeah.
it was, all of a sudden you're like, oh, yeah, maybe we should put this in.
Yeah.
Little things even, it was like, holy buckets. And I mean, I've been doing this for years, but even for me to see it when it was going on was quite interesting. But yeah, I mean, just even like small things, they're like, oh, hey, well, actually, I just noticed. I'm like, oh, I got like 5 of those. So yeah, let's go cover those up real quick.
Or one dryer vent in a house.
Yep,
wasn't
one dryer
sealed.
vent,
Or
yep.
one window the seal wasn't quite closed, and that blows it. So when you get to the end, these are very tight buildings, and along with tightness, and so Brandon gets to keep track and push trades and find those leaks where they happen inadvertently. But also along with it is the importance to ventilate the buildings very well. So there are energy recovery ventilation systems, because the more we make it tight, the more intense we have to integrate fresh air and intake and manage the ventilation system. So tightness goes along with the ventilation.
Yep.
One thing about the Carleton project that makes it very unique is that it's not only passive house buildings, but it's integrated with the campus district heat and cooling system. And so the whole carbon impact of the project is really doubled up, because the campus heating cooling system is what is the primary heating, cooling, and the system supplied to the buildings. So it's all on geothermal heat system that has a supplemental backup for the peak times in the winter. So the campus district heat system supplies heating, cooling, domestic hot water, plus the buildings are all connected to the campus electric grid system, which has an enhanced renewable component in addition to what the normal Excel grid system is. So that's where Rob's management of the campus district system really gives value to this. So there is no gas in any building. It's all electric based. Within the buildings, all of the main heating and cooling systems are just air handlers, 4-pipe air handlers in essence. And so that's for heating and cooling. There is no domestic hot water heating within the buildings. And so because of that, the carbon footprint for the buildings is already very low because of the district system. And this use of district systems in conjunction with efficient buildings is pretty rare. And there aren't many district systems other than college campuses and downtown areas of Minneapolis and St. Paul or Duluth, those kinds of places. And so that combination of district heating, cooling systems with tight buildings, high efficient envelopes, really gets it exceedingly efficient. So we were talking about thermal bridging.
Yeah.
And one of the ways that it's most obvious is the steel. You'll see it's just standing there, it's not connected. It's because steel transfers heat really well, and we don't want that. So we have no connections between the building and the steel columns at all. It's always connected by wood, but where the wood roofs meet, it's actually built with a thermal break. So it's a structural connection that we do so that it minimizes the heat transfer of the solid wood. It doesn't go all the way into the building.
This is where I'll say, watch your step.
Yeah, thank you.
Yep. Heads up. Be on your best behavior, Jody.
Thank you.
So this is the normal 6-inch stud people would have. This is the back side of a wall that has 4 inches of rigid insulation on the outside. And then this will be infilled. And then there's material that we'll see later that covers that up. And then inside that is the metal sacrificial wall. So,
Okay.
and then we'll also elsewhere see below the trusses, we put in the similar thing with rigid insulation, and then we blow the attic full. But that minimizes the thermal transfer from the roof trusses down into the building too. It's about R70.
R70.
Yep.
Okay.
Up there, and it's about R50 on the walls.
Okay.
And then the other thing you'll see, I mentioned that control of moisture through the wall. So on the outside, there's that pink color.
And is that kind of like the orange barrier, for lack of a better description, tied back on steroids?
Yeah.
Yes.
Okay.
Yep.
Except so we have to make sure that everything laps between the outside weather barrier, the orange
Right.
stuff, and the inside air barrier. So you'll see that tucked between this stuff is the air barrier, and it wraps around the whole building. So you'll see it in different places where they had to put this in as they put the next level on. And they all, the weather barrier on the outside comes through and overlaps with this stuff on the inside. So Brandon has to make sure that's in the sequence. It's a smart membrane. We really worry about trapping water in here, moisture.
Right.
And so we have to build the wall so it kind of can breathe, while this membrane has the capability of breathing.
Oh, okay.
So if moisture is in there, it can breathe in.
Okay.
And then the weather barrier also has a capability to breathe out. So,
Okay.
you know,
Interesting.
so it's ways to try to minimize having that much insulation and what happens if water gets in there. So.
And an additional thing to Kim's comment of the thermal bridging, you've noticed that typical framing is 16 inches on center, but with this framing, we actually have a wider spacing. Again, minimizing bridging because we have less in the wall space that can transfer the cold. So more insulation.
Right. Less bridging.
Yep.
Yep, so in that case, here we have a kitchen that's on an exterior wall, but none of that plumbing is actually in that warm wall. It's all inside. So when we talk about that sacrificial layer, that's going to be in here. So
Okay.
there is no plumbing built in an actual thermal wall.
Okay.
The inside of that regular wall, the purple stuff, this is where the normal sheetrock would be, is that purple stuff.
Okay.
And if you look up here, that's that bottom of the roof assembly where there's rigid insulation. And then this is the kind of stuff where we start to worry about wires. So these wires are in the insulation area, and that's where they have to, eventually they'll be caulking all those kind of penetrations. And so we just try to make sure that the holes happen where we want them to happen.
Yeah.
And that where there are holes, that they're sealed.
And that goes back to, I don't think I captured your awesome comment earlier, Brandon.
The more goo, more goo, the better. And what we're doing is, we're sealing from the underside, and then we're going up into the attic space as well and triple checking it. Again, just an extra measure to ensure that everything is sealed up.
So this is that air barrier again, and it happens up in the attic, and so it always drapes on the outside walls then.
And is it a breathable material? Is that right?
It's called a smart membrane.
So smart.
Somehow it has the capability of being, so there are permeability numbers, and this one has the capability of allowing moisture, not water, but air vapor to go through it. This is the exterior weather barrier, the goo,
Okay, yeah.
that goes in before the windows are installed, and then that's where these eventually have to lap.
Yep.
So-
Eventually we tie it together. So.
But this is where the normal building would stop, right here.
But
you'll
you're
see
having the
there's-
false wall.
Right,
Yep.
because there's
Go
nothing
here.
in this wall other than insulation. And then you can feel how sticky that is, even though it's,
Oh yeah. Yeah, it's tacky.
yeah. And then this is
And this
just-
has been done for a while.
yeah.
3 we just sprayed, I think it was Tuesday, Tuesday or Wednesday. And that is, you stick to it. So
Yeah, okay, yeah.
it definitely was a challenge. I know some of the trades have been in a little bit more of the lead, or where it's, they have to take a lot of this into consideration, but the FIAS and this passive takes it to another level, so to speak. And so coming from like what I used to do, this was, stick framing, okay, no biggie. Roughing in, most of it not an issue, but the extent of like care that has to be taken, attention to detail, to not miss little things. Like a pinhole can make a big difference. And so that took a lot for guys to just understand, like, hey, I get it if you've got to do this,
Right.
but I need to know about it so I can make sure it's sealed up properly.
Right.
And so just kind of reminding the guys, like, I'm not going to be, it's like talking to your kid. I'm not going to be mad,
Yeah.
but I need to know.
I need to know.
And I think a lot of guys, it just took them a little bit to understand that, and a lot of, it wasn't more of like, oh, I'm worried they're going to, we're going to get in trouble because we punched this hole in this wall. It just more so is they just weren't used to having to think about that.
You would just do it in a typical.
And as Kim had noted, we've got a lot of eyes on it, and I'm walking it consistently. We've got other guys that are walking consistently. When Kim is on site walking and doing his reports, they're a beneficial reminder of like, hey, yes, I know I need to do this. It's not in my sequence right now, but I'll keep an eye out on it type situation. Or if I just wanted off Kim's report, I'd do it.
Yeah.
Well, but you also, when we started on the smallest building, there was a refinement of some of the stuff that
Definitely was.
So
Learning curve.
lesson
Definitely
learned
was.
on the first building. It just took longer.
Yeah.
And then on integrating some of the systems, like when we get to the building insulated concrete forms and how the electrical gets integrated into that, there were issues in terms of how do you make that work more smoothly. And so the first building or two just took longer.
Right.
Yeah.
And,
yes.
and
we
then-
always knew it would.
Right.
We had always planned on these are our learning buildings, and then we want to start to increase our production a little bit more. And it is a bit of production construction in the sense of we're putting up a lot, but at the same time we have to remind guys it's not, because I don't want them to blow past something that's an important detail.
Right.
and so we got to just remind them, like, sometimes just, hey, hang on, let's take a minute. So we
Yeah.
kind of worked that into our schedule to make sure that we weren't super aggressive, but at the same time not lenient in the sense of that we're not going to make our date.
For sure. Yeah.
So.
I gotcha. Yeah.
The sealants tend to be very flexible sealants, and in some regular construction there are more latex sealants that are more brittle, and the flexible ones, they make things connect better, but also when you put a nail through it or a screw through it, they tend to be more self-healing. So like the weather barrier on the outside, part of that it is good for is that when you nail the siding to it, it self-heals all of those nails.
Okay.
Yeah.
So whereas Tyvek does the water moisture treatment well, it doesn't do anything about the healing of the nails and screws that go through it.
Okay.
So, but the weather barrier does.
Okay.
So that's where the weather barrier, it's a great product. But I mean, it's more expensive again, very labor intensive, because you see
It's really fun to try and glop that on.
I have not partaken in it at all myself, but it actually has been going a lot better this go around. We've been doing it's a spray applied now. It's before they rolled it, but they're spraying it on now.
Yeah.
It covers a little better and it goes faster, except for when it starts to get cold.
Okay.
So, but yeah, I mean, like to Kim's point, it doesn't like harden up to like like rock hard, so to speak. Like it doesn't feel like plywood. Months after, before we put siding on, like you could still tell there's some, I guess, pliability to it, so to speak. And so as like Kim had noted about the sealants is, one of the things we learned is some have movement, some don't. And that was one thing that we had to correct on some of them is the sealant worked, it sealed the joints, but for the movement of the building and to ensure that everything kind of stuck, we had to make sure we're, checking and verifying what we had. Again, something that everyone was used to using normally, but we had to change their thinking and be like, hey, it's a great product, it's just not what we're using.
We've got a blend of college construction with residential.
Okay. Yeah.
So not everyone in a residential construction that's mastic. In residential construction, you tend to see tape,
Okay. Right.
but mastic is more durable.
Right. Yeah.
But it is part of the FIAS thing of the duct sealant
Okay.
and leakage. And so one of the other things that has to be tested for FIAS is to ensure the ducts are working properly. So they'll actually test the ductwork for leakage and find areas where they might be losing air. And then we've been doing that before we actually insulate to make sure that everything in the floor is good.
Right.
Any ductwork that goes in below, which we'll see over in 5, they then have to seal that connection, and then they test the system again.
Okay.
And then, so that's kind of more around that final testing zone where they're like, okay, make sure everything's sealed, and then they also do like a CFM testing on it as well.
Okay. Got it.
So anyway, that's the supply and return for the heating, supply and return for cold water, domestic hot water, supply and return, and then domestic water. So this is just because of the district heating system.
That's so cool.
And underground outside, you wouldn't know it, the maze of piping. That's just underground. So
This larger set here, which would be your heating,
Yeah.
and then there's 2 smaller sets over there that would be your cooling. Those would get connected to essentially a fan coil unit.
Yeah.
The 3 over here that are in the middle, they're the smallest of them. That's your domestic water, so your drinking water, your
fire protection.
fire protection, and those will just essentially be pipe direct and feed all the fixtures in the house.
One of the things about FIAS is that there's also a limit to the length from where the ERVs, heat recovery, energy recovery ventilators are, and the exterior. You need them as short as possible. And so in this building, the recovery units are down below, and they go right outside here. So it's only, we tried to keep them, I forget, under like 12 feet.
And some we do have challenges with. I know this building specifically, we have some challenges. But again, it's something that we have to work through on the design end of checking to make sure that it still meets requirements.
So that's where, this is the supply and return for the ERV. And then the other thing, I mentioned that pipe on the other building. This happens to be a kitchen again. So this is the riser for the vent on the kitchen sink. And instead of being, it just gets a thicker metal stud here. For those few exceptions to not having plumbing by an exterior wall. It's not in the exterior wall technically, but it's adjacent to the exterior wall.
And Kim, dumb question, I just want to make sure I understand the ERP. So it's the idea that this is where we're pulling fresh air in, but when we do that, we have to get rid of stale air.
Yeah,
but
so
we want to preheat it or pre-cool it.
yeah, so you have two pipes from the outside,
Yeah.
and you have two from the inside. You have an air coming in from the outside into this box, and then it passes and cross paths with air from the inside that goes outside, and it either preheats or cools
Right.
the air. It never mixes.
Right, but the heat is
But
transferring.
it transfers within that box, and then within the box there's also some humidity, that condensation that comes out of the air.
Okay.
And whether it's heating or cooling, that change happens.
Okay.
So,
Gotcha.
so that the fresh air that comes into the building is tempered before it gets to the air handler.
Right.
And then you extract heating or cooling depending on the season
Right.
for the air that's coming in.
Right. Because like right now we spent all this energy, once it's done, to heat the inside air. We don't just want to throw it out and pull
Yep.
in cold air.
And that's become more typical within single family, and now in multifamily it will become essentially mandatory.
Okay.
So that's a recent change to it.
Got it.
So.
Okay.
So all the windows are they're triple glazed
Okay.
with a fiberglass frame, and depending on the orientation and the shading from the exterior side, the glazing is different. So some is the solar heat gain coefficients are slightly different based on orientation. There's some more concern about overheating. And the other thing is that there's slightly less window area
Right.
to the wall area in these buildings. And
Right.
so trying to be intentional about where the glass is placed, because it's kind of like you have a budget for how much glass you can put in the building. And so you try
For
to put it where
airtightness purposes.
No, it's for the it's part of the window to wall ratio.
Oh, right. That's
It's a
part of the certification, right? Yep.
somehow the math on the modeling has to be done so that you just can't get too much glass area, partly for the fear of overheating.
Yeah.
Oh, is it for overheating?
Yeah, too much solar gain.
Components that do need to go outside.
Okay. Yeah.
So you've got an outlet that has to go be placed on the porch, and then this is your door access control.
Okay. Yes, it's a communication line. Okay.
And so those have to go out. He just hasn't sealed it yet. So you can see the electrician's done his sealant.
Yeah.
So what we do is we seal on the interior side,
Yeah.
and then we go outside, and it's sitting in an electrical box. So the wire is out of the wall, sealed to the wall.
Yeah.
Electrical box is pushed onto it, and then they sealed it around the outside of the electrical box as well.
Okay. Yeah.
For as more goo
Yeah,
as much as
there you go.
possible.
Yeah, for sure.
But then we also did the exterior siding with a panel that tends to have all of those things in this panel on the outside.
Okay.
And it's built not so that it's outside of that rigid insulation wall. It's actually another panel, kind of like this, on the outside, where we've grouped all that kind of things together.
Right. Okay.
So it's one area that just gets more attention.
Yep.
Okay.
Rather than kind of all over the place. It's we
Because
try to-
otherwise they would have had to cut that rigid insulation, set their box inside of that. So
Right.
now you're adding just more breaks in the overall air barrier.
Right.
So instead of a 4-inch square, you've got a 1-inch hole or 3/4 inch hole.
Okay.
So-
Yeah.
So
Gotcha.
but this is that, in this case, this has the plumbing,
Yeah.
and it's all inside, not in a normal house. All of this stuff would be in the wall. And so, again, having as few penetrations as possible. It's kind of hard for an electrician to inadvertently put a hole in this sheathing.
Mm-hmm.
It's possible, but that's where they've gotten the message. I mean, to be sensitive about that stuff. And so they just do their normal thing in this wall. Right?
Okay.
Right?
Below trusses, so all the ductwork's below lid, the permanent lid. But basically, on the lower levels, we'll sheetrock where we have these soffits, and that ductwork, that'll be like their main trunk that is, supplying and returns to the floors. So what you saw down below, there's all this ductwork that's running in the floor trusses.
Right.
They have to make a connection to another piece of duct below the sheetrock. So when they do that, there's an additional sealant that has to happen there too.
Okay.
So we test everything in the floor system. Okay, it's all doing good, and then we add this other one, test that. All right, it's holding. At that point, we allow ourselves to start covering things up.
Okay.
So by doing that additional testing, we know this is sealed up right now,
Gotcha.
and then we do an additional section of testing. So,
Okay.
and that allows us to cover.
So like those wire penetrations there, that's sealed. And then eventually when they get downstairs, on those walls where those miscellaneous wires weren't sealed yet, that's where they'll get to it.
Gotcha. Okay. Yeah.
I mean, there'll be one more layer of sheetrock, and then Brandon said that this verifying this continuity of the moisture barrier, air barriers in here will be done, and then the sheetrock goes on.
Gotcha.
And the sheetrock goes around the window and
Yep.
interior.
Yeah, this sheetrock returns on
It's a
the
sill.
head and the jambs, and then it's a solid surface sill, like a windowsill.
Yeah.
So,
This is a sweet view. Like just of the
Yeah,
city.
this is
Yeah.
a lucky person whose
Well-
corner office is this gonna be.
Wendy, that was amazing. That was really fun to see. And just for all of you, like that's like hot off the press. Wendy just finished editing, and kind of like a rough edit. And so you are seeing this for the very first time.
That's true. This is you have a direct access to a filmmaker's rough cut of this footage, and
Yeah,
this will be
I
used
thought
to
that was
support.
pretty cool.
Yeah. Mhm.
So for everyone, drop your questions in the chat. And I just want to thank Wendy. She worked really hard to get this cropped so we could fit it into a decarb debrief session. And so thank you, Wendy, for your work on this session 10 of decarb debrief. Martha has joined us as well, Martha also supported Hillcrest Village with me. With the board of directors for the Northfield project. So if you have general passive house questions, we can put that in the chat too. While folks are doing questions, I have one from James, but one that I have right away is
Ooh, great question, James.
That
I
is-
think asking the same question you were about to, Alex, if I can be.
yeah, please do. Go ahead.
Sorry.
James.
So the price difference between a passive and regular house, PS publishes the price differentiator can vary. I will say that, but 3 to 5% more for passive house is an average that they
3 to
publish.
5%. That's less than I thought.
Yeah, and I think it depends on materials and the reasons for selecting different materials for sure. But it is surprising how it is not much more expensive than one might think.
And
Great
James, I
question.
did add you to our chat if you wanted to follow up.
That's informative. I guess I wonder, they're framing 2 walls. I feel like that would probably be where is that not
Yeah,
like double the labor, or
Yeah,
certain
I
amount of
think
labor additions, and then you've got like this like goo that they kind of like paste onto the outside wall as
yep.
well.
Yep.
That's more labor, so it's
Yeah,
the
they
materials are a little bit
touched
more
they
expensive too.
touched on this. So materials can be a little bit more expensive. I think one of the bigger price points is in this case triple pane windows instead of double pane. That's a higher price point. There was a section too about how they were from Colorado, and I was asking about the balloons because they're having to let it acclimate to the pressure here in Northfield, and there was a whole thing about that. That was interesting, but. Um, I can ask like what the price differentiation would have been maybe for standard construction for Carleton. I don't have that data. But there was also a section where they said in terms of the labor, they kind of knew the first couple were going to be pretty more expensive as they were figuring things out. But as they got in the groove, it's not that much more. It's just sort of a different way of working. So I feel like Brandon gave us a little bit of insight into the crew that has done, if they've done these before, it's not going to be that much of an additional labor cost. But if it's their first time, you're going to want to plan in for the first few buildings being additional labor as they work out the kinks. So great question, James.
I'd be interested in seeing that comparison, but thank you.
Yeah, I don't know if they have that data necessarily because they never really planned to build houses that were standard, but I bet LHB might hook me up with something. Kim's smart. So.
Thanks,
Oh,
Jesse.
actually, Kim uh, did another project in Minneapolis where they built two buildings side by side, one that was passive and one that was code. And they did compare the differences. So I think I could pull that. So
Awesome. Thanks, James. Wendy, what was something that you found that really surprised you during this tour?
I think it was just the testing, like how in depth that is. And it totally makes sense of like we do the blower test early and often because we have to locate where the heck those holes are. Once something is closed up, it becomes impossible or much harder to find where it was. So if they're testing along the way, they're going to debug those issues as they go. And my background before I came to RMF was coding, and that's how we build a piece of software too. You're going to want to find your bugs early before you build a whole thing around a giant issue that you have to completely reprogram later. So it's a very similar idea, and I love that how attentive Brandon was and how he was managing his team to do that so well. I even loved like talking like a dad, like I'm not going to be mad if you make a hole, but you have to tell me.
Wendy, on that note, what are the next steps for a contractor like this who now has this experience in their portfolio? Did they mention anything about trying to do it again for other clients or opportunities to
That's a good
continue?
question. Terra Construction is a very cool animal because they actually had, remember, we met a team member who had a construction certification from FIAS. So like they're investing pretty heavily in knowing how to do this. I think that it's still catching on in Minnesota. That's something that my documentary hopes to do is educate more consumers and more business owners about the importance of it, so that it catches on more. But Tara, I think, is definitely investing in having this skill and utilizing it for their clients.
They see a future for those
Yeah.
skills in their business model.
Yeah, Wendy, Andy put a good question in the chat too about what does this mean when the building needs change and we need to add new holes? How does that affect the building in the future?
That's a good question. I think that there would be a lot of barriers up to changing it very much from within the inside. Like all of the interior walls don't really have much insulation, between the framing of like, say this room is this size and we're going to expand the footprint to double. So I think that interior wall may not be touched with. I think that's going to be off limits. Adding an addition to a space, I don't know how they would handle that. But I feel like since this is residential, it's probably pretty unlikely that the footprint would change.
Yeah, I was
It would
gonna
be
say
more the interior
college.
walls. Yeah,
Yeah,
and
the
the
college
framing,
view.
the framing from room to room is pretty standard construction. They talked about that a little bit more in depth. It doesn't have the same insulation as the full wraparound, but it does have some a little bit more than usual for sound, just because you're in a dorm. And yeah, it had like double the sheetrock or something like that.
It sounds like the exterior shell is really the tank.
Yeah,
With the
that's
winter
the
jacket.
non-negotiable. Yep.
Right, non-negotiable. But if you were to make interior renovations with that interior double wall, that's almost the purpose of the double wall, is that you have flexibility
Totally.
inside to
Yep.
move things or poke holes, as long as you
Run new
maintain the
electric,
integrity
run new
of the
plumbing, because
outside.
that's all in that inside
Mhm.
wall. Yep. Mm-hmm.
Awesome. Well, we're almost at time, Wendy, and I don't see any other questions in the chat. So I just wanted to say thank you for switching roles and playing the subject matter expert today and sharing your filmmaking talents with us. And thank you to all of you who tuned in today. We will be sending out the recording, or it'll be posted on the pipeline if you want to reference this again. Stay tuned for the next session and have a great day, everyone.
Yeah, I'd just like to thank Carleton one more time for being so generous with their time with me. I think that having that look under the hood of these multiple buildings at slightly different stages of construction, of being able to see what exterior wall is versus interior framing, the double wall, that was all super mind expanding for me, seeing that vapor barrier, seeing the goo on the outside, like all of these really cool new innovative technologies that they were willing to share is awesome. So
Is
shout
goo
out.
a technical term?
It is. I learned it from Brandon. He's in the trade.
Love it. Well, thank you all and enjoy your afternoon.
Thanks.
Bye.
Bye.